Yo, so this is going to be a short retrospective of the GMTK Game Jam 2025, and I participated alone, so I was the solo programmer, and last minute I messaged someone to make the music and help with the design. So other than that, I did all of the programming on this game. And the tools were Jai for programming language and Raylib for rendering audio and input. And the goal I had before was to simply make something. The goal wasn't to make something that's like super fun or super like going for the win or something, just making something, since this is the first jam I'm doing as a solo programmer, and it's the first jam I'm doing with Jai and Raylib. And I wanted to try out some compile time stuff, since that's a very neat feature in Jai. And I wanted to use my simple entity structure code that I prototyped a week before the jam. So the game, I'm gonna show you real quick what it looks like. First I'm gonna show you a compile. So you can see it compiles very fast. That's a neat feature. Really helped iterating during the jam. And so this is the game. It's an ASCII based top-down like dungeon crawler thing, where I am the tinkerer right now. I can open levers, I can cycle through each character, and each character has a different trait. Like the bomb carrier can either explode or it can step on these kill tiles. So I'm gonna explode. Yeah, so you can see that I exploded all of the walls right there. And there are enemies, of course. They follow you using pathfinding. It's turn-based, and the game just crashed. I think I had something. A search of it. Yeah, I think I did something that doesn't exist in the final executable. Let's see if that was because I compiled with x64 backend. I'm just gonna check. Sorry, I want to make sure that this isn't a... Let's see. No, I think we're good. Alright, so the game starts. I press X, there's a transition, and we get presented the view of the entire map. And so you get to plan, like you get to pick, you have 3 slots, you get to pick 3 characters from the 5 available to you. So you can kind of see the map. You can think like, oh, there's like 2-3 doors down here, there's a couple of kill tiles, I want to get into here, so I have to pick either the bomb character or I have to pick the dig character. And yeah, so that's essentially the game. The design isn't the best, but it works. You can play the game and you can finish it. There is like basic lighting, as you can see. The player lights up the map as he walks around. So for example, right here, if I want to kill this enemy here, I am going to place a wall here and a wall there, and I can use the dasher. I can dash over here and I can dash into the enemy. And the goal for each iteration you reach the goal down here. Like I'm in editing mode. The goal is to find the exit, and then you loop back, and all the modifications that you did, like for example placing a wall or digging up a tile or exploding, will persist through each iteration, each loop. And also there's an editing mode I coded, so you can press tiles and you can delete them. I'm deleting in the upper right now, and I can place new tiles. For example, I can delete all of these, and I can create let's create like a laser here, and let's place like a dig ball here, and I'm gonna replace so now I have a laser here. You can see the laser is blocked by the diggable tile, and I can like dig up the diggable tile. And so there's a lot of interactivity. I think it's a pretty complex game, like implementation wise for a game jam game. Yeah. So as I said, the game isn't, I don't think it's super good. The design didn't pan out. Like we made procedurally generated maps as well, like segments, like how Spelunky does it, where you generate segments and you puzzle them together so they fit. We did that, which is kind of a, in hindsight, it wasn't the best decision for a game jam game. I would have much preferred if we handcrafted like 2 different levels, or maybe just 1 level that we handcrafted. And yeah, the game is also super hard to understand. Like I understand the game, of course. I understand every mechanic and how everything interacts, but a new player, I don't think any players will fully understand all the complexity. Since no one is going to spend more than 10 minutes playing, and no one is going to put in the time to actually understand everything, since it's a game jam game. Yeah, that's kind of a pitfall of the design. Let's see, do I have any more thoughts on the game? Yeah, not really. I think it was a good idea, but execution wise, a bit iffy. So the code, it's in Jai. I had all of the game code is in one file, and that file is this long, 2,700 lines, and that's the entire gameplay code. I have some extra code for like example. I have a ASCII math file where I just have a couple of functions like line of sight from one tile to another, the A star for the enemy, the lightning calculation, neighbor, yeah, sort of like basic math algorithm stuff I have in this file. The levels looks like this. So we created levels in the game, then I created a way to export them out to a string character, which we then save to file. And then during compile time, in the segments in this file, we load each text file, so all of these text files, we load as an array of strings into each thing. A bad comment, but yeah, so we create these 4 arrays, which at compile time gets filled up with each element is just the characters in the file. So that's the compile time stuff I did, basically. Not that complicated, but it works. It was quite fast to create levels and export them and then get them into the game. So that's neat. And we can say I use this. The compile time stuff comes from this #run, and we can define like this segment, this block of code you should run at compile time, and it will return you an array of strings, and then store that in the top left, a variable called top left. So then this variable becomes of the type array of strings generated by this code. And this compile time code opens a file and reads from the file. Yeah, so it's super cool. And this code is readable. It's just Jai code, but inside a #run directive. So that I'm pretty happy with. And as I said, I used like a super simple entity system, and it uses, it's nothing tricky. The only like thing I did that's interesting is that each entity, like there's a mega struct, so every entity is this struct, and this struct has everything an entity would need just available. And the way I differentiate between like a door and a lever is this enum value, and then this enum value places the entity in a lookup table for like faster iteration. So if I want all the doors, I don't have to iterate through all the entities. I can simply say, give me the array of pointers that's all the doors, and all the entities still exist in this array, but I also have a pointer, like table of pointers to each kind. Yeah. So these are all the enemy kinds, or entity kinds, sorry. Not super many, maybe quite many for a Game Jam game, like 4 days of development, 3 days of development. So we had door, and we had a player, the enemy, a wall, a door, a lever, the kill tile. We also have fire, there's a dead character, there's the diggable wall, the goal, the laser, fireball, yeah. So all of the different entities is stored in this enum. And then I have a bunch of create functions, like create goal. I have a create function for each entity kind, and this sets up an entity. Like it says the kind, it's a goal, it places it somewhere, gives it a color, gives it a glyph character, and then it assigns the procedures for that entity kind. Like the goal will have its own update function that's different from the enemy update function, and that is stored as a function pointer inside the entity. So then when I loop, when I loop, I just loop through every entity and call its update procedure. Cool. Same for the render. I just loop for every entity and call its render procedure, so that each entity can like do its own thing. I also have the systems, since in this game every entity is rendered the exact same way. They are just characters in a position. So I have a system for that just assigns the cell character here, like it takes the entity's glyph, the entity's color and background, and assigns it to the draw buffer, this buffer, global variable of every tile where a character exists on the screen. Yeah, and this system then also performs the lightning, the fake light, sorry, down here, the update system, the update render system, performs the calculation of the alpha, which then acts as the lighting. Yeah, let's see if there's anything else I want to dig through. Of course there's sounds as well, which I think you heard when I played. Hopefully that wasn't too loud. But yeah, another basic system which I could have done this compile time, like generate this array at compile time, since it's a folder with just a bunch of files, but there was no time for it. I did the sounds the last day, which is a bad idea, but yeah. So there's just an array of strings, and then down here I just iterate and load the sound into a table where the key is the file name, and the value is the sound that you want to play, like the actual sound data. So then when you want to play a sound, you simply give it a name, and it tries to find in the table that sound, and then it plays the sound. Pretty standard way. I've done this exact same thing for other games before. Let's see if there's anything other interesting. We can maybe look for the main one. So the main does not that much. I mean, this is the initialization. Let's see. Yeah, this is the initialization code. Of course, this calls out a bunch of other stuff to initialize the game. But yeah, we set the random seed. We do some basic Raylib initialization. We initialize the entity world, which doesn't do much. Then we give it all of the different update systems, all the render systems, and we always just at the start, always create the player. And then we create this tutorial box, which inserts a bunch of entities. All of these entities, this is the menu, and the create tutorial box just creates this. And then when I press X to play, we clear the entire world except for the player. We keep the player, and we create the actual level, and we place the player somewhere that's where he's supposed to be at the start of the game. So that's why we can create the player and we never delete the player. He always exists. Yeah, some game state stuff, assigning characters, pushing some commands to the entity world, initializing sound effects, initializing music, and then we have the main loop. And this is an interesting part. Jai comes with this example, I guess. It's a I don't know what to call it, a tool, a visualization tool. So this is a program that comes with the Jai compiler. And if I launch the game now, since I call this function every frame, it will automatically hook into yeah, you can see. So this is the game right now as it's being played. You can see that when I move, it allocates something, and if I change character, it allocates some strings that gets cleaned up. Yeah, so you can see right now the game has 29 allocations, and it's this many bytes being allocated on the heap. Yeah, so I use this tool to detect, like, I think I had one memory leak early on that I detected for this. So that's nice. I also had this codex view, which is pretty interesting as well. So if you compile the game, just as I did before, but you give it a plugin you give the codex plugin, which is again something that comes with the Jai compiler. And a plugin is something that I think runs in the meta program, and the meta program is something that sits in the compiler space, in the compile time space. So you can jack in and do stuff at compile time. So I give it the codex plugin, and now it says codex has created this exported codex file. And that file is here, and I can drag this into this graph view. And now we get this like overview of the code, and this is very cool. I think that you get to use this. So I can see that I can split it by modules, or modules of files. If I do modules, this center part here is my code. As you can see in the lower left, you can see that it's under GI Jam Gnarly, which is the game folder. Then over here we have the Jai compiler modules basic. Over here we have some more Jai compiler stuff. Jai compiler. Yeah, and then you can see that the coloring is, I don't know exactly how it's coloring. I think it's based on the values in the lower right. You can see that we have date. So this is the main function, and then we have in the lower right we can see how many if points there are. We can see the maximum loop, the maximum if depth, the maximum loop depth, which is just the main loop, I think, the game loop. Yeah, we can see this for each function. For example, this create tutorial box is very blue, and I think that's because it doesn't have any if, it doesn't have any loops or nothing, no LK, it just calls out to other functions. So it's, I guess it's very cold. It's not dynamic, it's very static, just calls out to a bunch of functions. And then like the editor system is super, like it has 154 if statements. That's a lot of ifs in one function, and maybe that's why this one is a little bit warmer in color, since it's very dynamic. It has a lot of paths. I don't know, just guessing. Let's see. Yeah, like all of these create functions are very blue. Create door, create goal, create wall. Is basic rendered is also just one singular expression. Get segment start. Yeah. I wonder where. Let me try to find. There's the fireball update. Let me try to find, like, yeah, that's enemy update. There, update player is one hell of a function. That contains a lot of logic. Like the majority of the logic exists inside update player. Yeah, we can see how big it is, how many ifs. This one has more ifs points than the edit system. Interesting. Yeah, so you can see, you can kind of look and get a overhead view of your code, which is super cool. I think it's interesting. I think there's nothing really more here. Some kind of, I think Jonathan Blow uses Emacs and he has some thing for this. I don't know, but I'm interested. I have used this one very much. Like I have it on. I had it on all the time in my other monitor, just to see that I didn't have any leaks or I was allocating too much memory. Cool. So the game is available on Edge. We didn't get any web build up, but there's a Mac build and a Windows build up, and all of the code is up on GitHub. I don't know if you're interested. It's very gnarly. The code is not the best code I've written, but it's a game and it works, so that's all that matters for a game jam. Cool. Hopefully this was somewhat interesting. I thought my conclusion is that using Jive for a game jam, and of course it's a language you can use anything for a game jam, but I will probably use Jive again for another game jam. I just enjoy all the different things you can do. I didn't even touch any sort of meta programming. I don't know why you would do that for a game jam. I don't know if it's even realistic or smart to go into meta programming for a game jam. Yeah, but you have the possibility, and it feels it's a good feeling to code in this language overall. Right. Thank you and bye bye.